Greetings, students. This is Mr. Torgerson. Today we're going to be going over the other 35 questions from your practice file. Let's begin. Question 41, arc length. So the arc length out of the angle is equal to the entire circumference of the circle, 2 pi times the radius, out of 360. So in other words, what I'm going to do here is I'm going to multiply 2 by 12, then I'm going to multiply that by 150 and divide by 360. And so we're going to reduce that. Now the pi here, we're going to leave it as part of our answer. That way we can have our answer in terms of pi. So I got 2 times by 12 times by 150 dividing by 360. 10. 10 pi is my answer. Again, I didn't multiply by the pi here because I want my answer in terms of pi. Now if you're doing this by hand, you're going to reduce here with the 12 and the 360. 12 goes into 360, goes in there 30 times, so that'll become 2 pi over 30. Then 2 into 30 makes that into a 15. So you would have 150 divided by 15, which is still 10 pi. Sector area, same deal, except it's going to be, instead of 2 pi r squared. So my area, my sector, x over 90 is equal to pi times r squared, radius is 14, out of 360. So I'm going to take 14 squared, times it by 90, and divide it by 360. Again, I want my answer in terms of pi. So that would be 49 pi. And again, if you're doing this by hand, and I should put my units here, square miles. Forgot to do that on the last one, miles. So again, if you're doing this by hand, you're going to take 90 into 360. That goes 4 times. You're going to take 14 squared, 256, and then divide that by 4. Actually, 14 squared isn't 256. It's 196. 196 divided by 4. All right, so these two questions, pi r squared, area of a circle, divided by 360, times by the portion of the circle you have. Circumference of the circle divided by 360, times by the portion of the circle you have. Moving on. Surface area. All right, I will give you the surface area form here. I'll write it on the board. Surface area of a pyramid is equal to the area of the base plus I want to say it's half, yeah. Half the perimeter times the slant height, which we call L. So that's the way I'm going to write it up on the board. So the base here is 11 by 11. It's a square pyramid, 121. The perimeter of the base, it's a square base. So again, it's got 11 for each of its sides, and there's 4 of them. 11 by 4, 44. And the slant height is clearly labeled as 12 3/10 of a centimeter. So what I have here is I have 121 plus half of 44 times by 12 3/10. Now I did format this question on the exam so that the decimal is more manageable, so that you guys that are not using a calculator can do this by hand. So it will not require a calculator. So 121 plus 1/2 times 44 times 12 3/10 is equal to 391 6/10 square centimeters. All right, so you will be provided with the form here on the exam. That will be given. You will have to understand what the area of the base is, that it's the base, it's a square base, what the perimeter of the base means, which means that you're adding the sides together, and that this is the slant height. I will have the slant height labeled here. It will not be labeled with the vertical height. It'll be labeled with the slant height because that's what you need for this. All right, cylinder. So this one is the area, 2 times the area of the base for a cylinder, because there's 2 bases, top and bottom, or left and right in this case, plus the perimeter of the base times the slant height. You can call that PC because the perimeter of a circle is the circumference of said circle. And you can call this H actually, because it's not a slanted height, it's just a normal height. All right, so the base here is pi r squared, the radius here being 11, not 22. So that's 121 pi. The perimeter of the base is the perimeter of said circle. So 2 pi r, 2 pi times 11, 22 pi. So I have here 2 times 121 pi plus 22 pi times and by 10. So I got 2 times 121, which is 242, plus 220. 462 pi is my finished answer here. This is in square feet again. You will be provided with the formula, so this will be given. You'll have to understand that this B means the area of the base, the area of this circle, pi r squared, and that this P represents the perimeter of the said circle, 2 pi r. All right, spheres. I'm looking for surface area. I've forgotten the formula here. Let me look it up in my book. 4 pi r squared. You'll be given the formula. 4 pi times the radius squared. All that goes in here is the radius. So again, you will be provided with this, given. The radius goes in. If I have labeled the diameter on the sphere, you make sure you cut it in half when you're doing the form. 4 pi times 10 squared. Do the squared first, so that becomes 100 times 4. Becomes 4 pi times 100, 400 pi square centimeters. Gotta like this. Gotta like the ball, the sphere. It's one of the easier shapes to do. Next one, surface area of a prism. It's the same form as the cylinder, so you'll be given the form as well. So the surface area, 2 times the base plus the perimeter times the height. So again, you have to understand that the base here is a square base, the 3 by 3. You can actually use either. You can actually use either the 3 by 3 as the base or the 3 by 6 as the base. I tend to use the 3 by 3 because it makes it so it's a square base. Anyway, so if I'm using the 3 by 3 as my base, the perimeter of said base is 3 times 4, because again it's a square base. 3 by 4, 12. And my height would be the 6. So I got 2 bases, 2 times 9, plus my perimeter times my height, 12 times by 6. So 18 plus 72 is 90 square kilometers. Surface area. Again, you will be provided with the form. You'll have to understand the base here is a square base, or you can use the rectangle with the prism. And that the perimeter is, again, the perimeter of said base, 4 sides, in this case of 3. Now, if you're using the 3 by 6 as your base, you would have a 3, a 6, a 3, and a 6, 2 sides of 3, and 2 sides of 6 as your perimeter. So be attentive to what you're going to use as your base. If you're using the 3 by 3, it's 3 sides of 4, or it's 4 sides of 3. If you're using the 3 by 6, it's 2 sides of 3, 2 sides of 6. All right. Next one's volume. Starting with a cone. Volume of a cone. 1/3 pi r squared times the height. Again, this will be given. I'll have it up on the board. It'll be given the form. So the radius is 2. Again, if I label this as a diameter, make sure you cut it in half. So the diameter here would be 4. Make sure you'd have to cut it in half to 2 if I labeled it that way. The height here again needs to be vertical. It'll be labeled vertically though. So I will not try to confuse you here on the question. 1/3 pi times 2 squared times 8. So 2 squared is 4, times by 8 is 32. So you'd have 32 over 3 pi, 32 thirds pi. You can write that as a fraction or a decimal or a mixed number. So I got 4 times 8, 32 pi over 3. This is in cubic feet. All right, prism, length times width times height. Or the area of the base times the height, B times H. So I could put it either way. Or base times the height. So the length, the width, and height here is the 1, the 3, and the 6. So 1 times 3 times 6 is 18 cubic miles. Again, you'll be provided with the form. You won't have to memorize the form. Sorry. I was working them out and I didn't have the camera set. But you'll be provided with both forms here. You won't have to memorize the forms. All you got to do is know how to use them. All right, moving along. This is a pyramid. So the volume is 1/3 the area of the base times the height, vertical height. So this is a triangle base. So the area of this base is 8 by 6 divided by 2. This 10 on this base is not going to be used. This diagonal, it's not going to be used. That's the diagonal on the right triangle. So I got 1/3 of 10 times 6. And again, I'm dividing that by 2 because I'm using a triangle as my base. So half of 10 by 6. So in other words, it's going to be 10 by 6, 6 by 6, 8 by 6, sorry. I was just saying don't use the 10 for your base. And I use the 10. It's 8 by 6, my triangle, not 10 by 6. Because I want the length times the width divided by 2. And then the 10 is my height. This 10 vertical. So half of 6 is 3. 3 divided by 3 is 3. 8 times 10 is 80. This is 80 cubic centimeters. Again, you'll be provided with the form, but you have to understand here that the area of the base is the triangle. B stands for the triangle base, 8 by 6 divided by 2. So in other words, half of 48 or 24. All right, next one here. Volume of a sphere. We'll look this one up in the book. 4/3 pi r cubed. Again, you'll be given the form. 4/3 pi times the radius cubed. So this is equal to 4/3 pi times by 9 cubed. Again, I will make this more manageable on the test. For those of you working without the calculator, it will be able to be done without the calculator. So 9 cubed is 729 and divided by 3 is 243 and times by 4, 972 pi cubic yards. These are more manageable on the actual exam. When I made the practice here, I made these a little more quickly than I did the final exam questions. So they will be smaller numbers. You'll be able to do them without the calculator, those of you working without the calculator. All right. Next one, polygons. If they're similar polygons, the side ratio should be the same. So I like to set this up as 3x plus 6 and 40. And then underneath the 3x plus 6 is the side it goes with, which is the 24. Underneath the 40 is the side it goes with, which is the 32. All right, and again, you're going to cross multiply. Hopefully you reduce before you cross multiply here, because you'll have an easier time if you do reduce, like here, 40 and 32. They both divide by 8. So I'd make this 5 and 4. And then here it also reduces 4 to 24. You can make that into a 6. So you can have an easier time because you're going to take 24 divided by 4 anyways. So that'll become a 1, and that'll become a 6. So you'd have 3x plus 6 times 1 equals 6 times 5, 30. Subtracting 6 from 30 yields 24, and dividing 24 by 3 yields 8. My answer. I made the numbers again more manageable on the test here. All right, question 52, cross multiply. You can also reduce before you cross multiply like I did in the last question, but these numbers are much smaller in the last question, so There's no real reason to. So 9 times x is 9x, and then 6 by 3 is 18. So x is 2. When I divide 9 by 18, I get 2. Anyways, so that's through number 52. You might want to save some of these for the last questions that you do, because some of these are longer to do in terms of their length of the questions. But that's entirely up to you when you're doing the final. You have the entire period to work on the final when we do the final exam. All right, so let's set up questions 53 through 58 here. So question 53. Find the missing length. The triangles are similar. So again, I'm going to set up a proportion here. So again, I like to put the same triangle in the numerator for both. And I like to put the sides that go together underneath. So PQ goes with ST. So PQ, my X, goes with ST. So these two go together. So the 39 goes here. And then the other one goes with the 40. Again, it's useful to reduce here, so I don't have to do large multiplication. So 40 and 30 make 4 and 3. And I can also do 3 into 39. Goes 13 times. So I'm going to take 13 times and by 4. That's going to be my answer, 52. And again, if you're working this by hand, that's what you're going to want to do. Reduce. Next one, tangent lines. Tangent lines are congruent when they meet outside of a circle. Two tangent lines to a circle are congruent when they meet outside the circle. So 8x plus 2 should be equal in value to 7x plus 7. So taking 7x from 8x, we yield x plus 2 is equal to 7. Taking 2 from 7, we yield 5. X is 5. All right, next one. Tangent lines on a polygon. Again, these tangent lines are congruent. So what I'm going to do here is I'm going to take this 9.2, 9 2/10. I'm going to copy it to here. That'll be the same length here, 9.2. I'm going to subtract it from 13.5. It's going to be 4.3. So that's 4.3. I'm going to subtract it from 16.3. That's going to be 12. Subtract it from 20.2. That's going to be 8.2, 8 2/10. So the missing length here is 8 2/10. So now I can add my 3 given sides plus the side in the bottom, the base. I did try to make this smaller on the actual exam, the numbers, so that you can do this easier by hand. So there's my 3 given sides. I got 8.2 and I got 9 2/10 here. There's my other 2 sides. So I got 16 3/10 plus 13 5/10 plus 20 2/10 plus 8 2/10 plus 9 2/10. I got 67 4/10. All right, transformations that preserve distance. There are 4 types of transformations. There are reflections, translations, rotations, and dilations. 3 of these 4 preserve distance. The one that does not preserve distance is the one that makes the shape bigger or smaller. So a reflection, all it does is reflect the shape, folds it over a line of symmetry. A translation, all it does is move a shape, left, right, up, or down. A rotation, what it does is it rotates a shape about a point, usually the origin. A dilation makes the shape bigger or smaller by a scale factor. So all 4 of these don't preserve distance, but 3 of the 4 do. The first 3, these 3. The dilation does not, because it makes the shape bigger or smaller. All right, describe the transformation. So we're going to use the words reflection, translation, dilation, or rotation here. So R went from here to here. So this is not a reflection. It's a rotation. In other words, the paper spun 180 degrees. Rotation, 180 degrees. Now we could go either clockwise or counterclockwise here because we're going half of a circle. So I could go counterclockwise to the left or clockwise, and I'd arrive at the same rotation. So it's not important here which direction we go, and it is about the origin. This is my center of rotation. All right, question 58. So T went from here to here. U went from here to here. This is a reflection. The line of symmetry is the line in the middle of T and its image, and U and its image. So in other words, T folded over this line to become its image, U folded over the line to become its image, and S folded over the line to become its image. It's a fold. T and U folded to the right, S folded to the left when it folded. So this is a reflection. And we could say on or across, x equals 2. Because that is my line of symmetry. X equals 2. This is x equals 2 because it's 2 to the right, this line of symmetry. All right, setting up the next page here. Give me a second. And we're back. So, find the coordinates of the vertices. Translations, 3 units right and 1 unit down. So I'm going to move everything 3 to the right, 1, 2, 3, 1 unit down. So there's the image of M. 3 to the right, 1 unit down. There's the image of L. 3 to the right, 1 unit down. There's the image of K. 3 to the right, 1 unit down. There's the image of N. So these are my 4 images. On the test, I made this multiple choice. So you'll have to pick the coordinates of the images. So you'll have to tell me where the locations are. In other words, you'll have to tell me that L's image is at -1, -2. K's image is at -1, -3. M's image is at 4, 0. And N's image is at 1, -4. So you'll have to pick the proper coordinates, in other words, from the multiple choice. All right, next one. Rotation, 180 degrees about the origin. So what I'm going to do here is I'm going to spin the paper halfway. So I do have a separate paper here to spin. So a rotation 180 about the origin, we can either go counterclockwise or clockwise. It would not really matter. So I'm going to go, here's 90, here's 180. Those are my new coordinates. So -1, -3, -4, -1, -4, -5. And in other words, they're all in quadrant 3. And it might be useful for you to spin your paper, write down the coordinates, and then plot them. So -1, -3, -4, -1, and then -4, -1, 2, 3, 4, 5. There's my image. So this is B's image, this is D's image, and this is C's image. And again, you'll have to match the coordinates with the proper option on the test. So -1, -3 for B, -4, -5 for C, and then -4, -1 for D. All right, dilations. Dilations are when you have a scale factor. So you multiply each of your points by said scale factor. So I'm going to take 3 halves times each of these coordinates to get my image of my dilation. So the image of T is equal to -2 times 3 halves. In other words, -2 times 3, -6 divided by 2, -3. -1 times 3 is -3 halves. I can leave that as a fraction if I want, or I can make it into -1.5. -2 times -3 is again -6 divided by 2 is -3. 1 times 3 halves is again 3 halves. I can have that as 3 halves or 1.5. 3 times 3 halves is 9 halves. It doesn't divide evenly. And 1 times 3 halves is 3 halves. Same deal here. That's still an image of 3 halves. So 1.5. So 1.5 times negative 2 is 3. 1.5 times negative 1 is 1.5. And again, all you're going to have to do is match the coordinates here. You won't have to perhaps find them all. You just have to match them. And then the other ones here, you would find them as well. Same way. 1.5 times 2 is 3. 1.5 times 0 is 0. 1.5 times 0 is 0. 1.5 times negative 3 is again 4.5. All right, next item. State if the triangles are similar. Then write the similarity statement. So to verify if a triangle is similar, it should have a similar side ratio. So my big triangle is 14 and 12. The size of my big triangle. So what I'm asking here is 14 and 12. Is that the same ratio? And I'm going to use the sides on the small triangle here. So I would use this 6 with the 7 here on the smaller triangle. So the 6 should go with the 12, and the 7 should go with the 14. And this is the same ratio. This is both 2 is equal to 2, yes. So these are, in fact, similar triangles. So L goes with itself, because that's the vertex of both triangles. K goes with G, and J goes with H. Again, this will be multiple choice. J goes with H. This will be multiple choice. So you just have to match the triangle together. You're going to have to verify that it is, in fact, similar. If it's not similar, there will be an option that says these triangles are not similar. All right, exterior angles. 360 divided by the number of sides. So this has 1, 2, 3, 4, 5 sides. So this is 360 divided by 5 for one exterior angle. 360 divided by 5 is 72 degrees. Again, what an exterior angle is an exterior angle outside of the shape. So this right here would be an exterior angle, or this right here. So these would all be 72, kind of like a Chinese throwing star. These would all be 72 degrees as we're coming around the pentagon. And I could also do it the other way as well. So if I wanted to, I could do the 72 degrees this way as well. These would all be 72 as well. 72 this way, 72 this way, 72 this way, and here as well. Either direction, they'd be 72 degrees. Anyways, interior angles. I like to do the supplement of the exterior angle. So again, I like to count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I like to do 360 divided by sides, which in this case is 360 divided by 9, which is 40. And I like to find the supplement of that because the interior and the exterior angles always supplement each other. In other words, if you look at this picture that we just did, 72 is the outside angle, 108 is the inside angle because they're a straight line. So I would finish this question by doing 180 minus 40. There's 140 degrees, which is the interior angle here on this shape. You can also find the interior angle directly by doing 180 minus 360 over the sides if you want to do a whole equation. So the whole equation would in fact be 180 minus 360 over the sides. Do 360 divided by sides first, though, before you subtract 180. All right, scale factor. So 3, 6, 6, and 3. So in other words, this is doubling. So my scale factor is 1 to 2. You could start it off as 3 to 6, 3 to 6, which it would become 1 to 2. I'm only going to have the reduced scale factor. I won't have the improper scale factor, the one that's not reduced. So if it does divide, 3 goes into 6 twice, make sure you divide it. Or you can just say that this one's twice as big in terms of the scale factor when you're looking at the answers here, multiple choice answers. Twice as big. All right, last page. 67 through 75. Similar triangles. Similar right triangles specifically, number 67. So again, I like to take the triangles that are on the same picture. So in this case, X is on the same one with 36, the small triangle. So I've got the small triangle here, X with 36. X is the hypotenuse, 36 is the short side. So X with 36. And again, this is the hypotenuse, this is the short side. So you got to keep it straight in your head. If you want to write it down next to the item. Hypotenuse, short side. So now I'm looking at the big triangle, the entire triangle, because that's what's labeled here. This is the short side, and this is the hypotenuse, the sum of 64 and 36. So in other words, what should go underneath here is X with the 36, because that's the short side on the big triangle. 36 was the short side on the small triangle. And underneath the X should be the sum of 64 and 36, 100. All right, so I've got X divided by 100 is equal to 36 over X. So X squared is equal to 36 times 100. You can do the roots separately here, or you can combine and then root. It'll give the same answer either way. So I can either do 6 by 10, because the square root of 36 is 6, the square root of 100 is 10, or I can do the square root of 3,600 to get the answer of 60. 60 degrees, no, not degrees, just 60. Sorry. All right, next question. Sides on a parallelogram are congruent. So 2 plus x is equal to 11, x is equal to 9. Next question. Ratios, length to area. So the area ratio is the square of the length ratio. So the options here, it's going to be multiple choice. The options here are going to provide you either the square of the ratio, half the ratio, double the ratio, or the same ratio. When you're converting side length into area, side length is length times width on a square or rectangle. So you're taking the length times the self. In other words, the area ratio here is 4 squared to 9 squared, 16 to 81. And when you're going backwards from the area ratio to the length ratio, you're square rooting it. So the square root of 25 to the square root of 49, 5 to 7. The way I keep it straight in my head is that area for a rectangle or for a square is length by width. So when I'm converting the length into the area, I multiply the length by the width. And these are not length and width separately. These are two separate shapes. This is like a square of side length 4 and a square of side length 9. So this is why it's 4 by 4. Two sides, it's got 4 sides of 4. This one's got 4 sides of 9. The area of this square is 4 by 4. The area of this square is 9 by 9. Whereas this is the given area of the square, 25 and 49, and I want the side lengths here. So 25 was 5 by 5 in terms of the square, and 49 was 7 by 7 in terms of the side lengths on the square. All right, geometric mean. The geometric mean is the multiplicative mean. So I'm going to multiply the numbers and then square root them. In other words, it's the number that's in between multiplicatively. So I can take the square root of 10 times 40 to get the geometric mean, which is 20. I can also attempt to do this without doing the actual multiplication and rooting by looking at the numbers and asking myself what is in between multiplicatively. So in this case, 10 times 2 would be 20, and 20 times 2 would be 40. 20 is the multiplicative mean because it's doubling. From 10 to 20, it's doubling, and then 20 to 40 would be doubling again. All right, this one's asking the question backwards. The geometric mean of 6 and another number is 96. So in other words, the square root of 6 times another number is equal to 96. Or you could think of it as 6 times something is equal to 96. Whoops. What was I going to say here? Yeah, I mean, the square root of 6 times x equals 96. is what I was looking for here. I did make the number smaller on the test. And you could also look at this as 6 times something. And I have this written on my key wrong. For you teachers out there, I do have this written on the key wrong. I meant to put this as a smaller number here. Let's just change the question. So I don't want to use 96 here because that's way too big. Let's use 48. 6 and another number is 48. Geometric mean of 6 and another number. Maybe it's even smaller than that. Maybe it's just 18. So in other words, the other number here would be 48, because 6 times 3 is equal to 18, and then 18 times 3 is equal to 48. So it's tripling each time. So what you can do here, you can say, what did I do to get from 6 to 18? I tripled. So to get from 18 to the finished answer, I'm going to triple again, 48. Again, I have this wrong on my key for you teachers out there. I'll fix it. I'll fix it today. But I didn't mean for this to be super huge. And I'll look through the final exam and I'll make sure it's not super huge as well. I'll make sure it's appropriate. If it's not, I'll change it for you. All right, question 73. So this is my side length, x. It goes with 8. Now this 27 doesn't go with the 10. It goes with the entire length there, 10 plus 8, 18. I'm going to take 18 times x and then 8 by 27. So 18x is equal to 216. And dividing 216 by 18 is going to yield 12 for my answer. All right, so next question. Once again, similar triangles. So here I've got the longest length, x. And here I've got the shortest length, 4. So I got x and I got 4. And I'm looking for a similar setup for the other triangle in terms of the ratios. So to set this up, I'm going to do the, well, I got to have this entire length, I got to have this 2 somewhere going with the 4 because they're across from the same angle, the short length. And the question is here, what does this question mark length go with? It doesn't go with 4, it goes with 6. Test it. It actually does go with the 4. Again, 2x is equal to 16, x is equal to 8. That's a difficult question to visualize. That's a difficult question to visualize there. So this hypotenuse x with the length 4, that's on the same triangle with it. This length here. Similar to this triangle here with the 4 and the 2. 4 being the long length, 2 being the short length. So again, I'm looking at the medium-sized triangle here, x with 4. 4 is across from this angle. X is the longest length on this. And then I'm looking at the small triangle here. 2 is across from the same angle that 4 was across on the medium triangle. And 4 is the longest length there. Difficult to visualize. All right, and then the last question, are the polygons similar? So I'm asking if the ratio is the same. So 12 and 30 are on this polygon, or on this rectangle, 12 and 30. 12 should go with the 4. So it does 12 divided by 4 equal 30 divided by 8. Well, 12 divided by 4 is 3. 30 divided by 8 is not 3. That's 3.5 or 3 3/4. Because 3/8 goes into 33 times 24 with 6 left over. 3 6/8. So no, these triangles, these polygons are not similar because this would be 15/4, not 3 3 3/4. Anyways, good luck on your final exams. I will be redoing question 72 if it's written improperly on the multiple choice. I will look at that one again. And again, the concept there with question number 72 was that 6 times something equals this number, and then this number times the same thing equals the finished answer. I could have actually used the 96 here, because if you take 96 divided by 6, you get 16. So my answer would be 96 times 16. But obviously, for those of you not using a calculator on the test, I don't want to be doing 96 by 16 for your finished answer here. So I did make it smaller on the test. I will make it smaller if it's not already done as a smaller number. Anyways, good luck. Hopefully this helps.